Good afternoon, Dr. Geeta. This is Jeevan Jyoti.
Good afternoon, ma'am.
Yeah, we'll start in 10 minutes. Like 2
Okay,
o'clock
ma'am.
we'll start.
Yes, ma'am.
Students are joining.
one left.
లేదు దీంట్లో 18 years.
Shravanti, you can start.
Just a minute, ma'am.
Good afternoon to all dear students. Today we are assembled here for a guest lecture by Dr. Geeta Verma, Assistant Professor, Department of Chemistry, Chandrasekhar Azad Government PG Nodal College, Madhya Pradesh. Madam, I take this opportunity to welcome you. And over to you, Shravanti.
Thank you, ma'am. Good afternoon, one and all. I am D. Shravanti, Assistant Professor in Department of Chemistry, RBI Women's College. It is a great honor and privilege to introduce Dr. Geeta Verma, ma'am, Assistant Professor, Department of Chemistry, Chandrasekhar Azad Government PG Nodal College, Sihor, Madhya Pradesh. Welcome, ma'am. Madam has done PhD from Central Drug Research Institute, Lucknow, and has completed her MSc in Organic Specialization from Lucknow University. Madam has published 22 research papers, including interdisciplinary topics in reputed international journals. And Madam is a life member of Association of Chemistry Teachers, and editorial board member in Journal Modern Chemistry 2018 to 2020. Madam has been awarded patent drug CDRA research work in 2003 for growth hormone releasing activity of synthesized hexapeptide. Madam has awarded as best professor in the year 2015 by Madhya Pradesh government. And also, Madam has facilitated by District Collector and Minister for Excellence in Education and Research on Independence Day 2016 and Republic Day 2018. And she is a recipient of Teaching Excellence Award 2016 by Indus Foundation Award at Indo-American Summit in Mumbai. Madam has been presented research papers in 4 European Congress at Spain in 2017 entitled Photo Reduction of Benzophenone using alternate solvent ethyl alcohol as a green solvent. And Madam is nominated for preparing e-content in 4 quadrant by Madhya Pradesh Government Higher Education Department for BSc first year National Education Policy 2020 syllabus. Madam has presented Best Paper Award selection by India's premier chemistry and chemical article writing competition conducted by Center of Chemistry and Chemical Excellence. With this brief introduction, now I invite Dr. Geeta Verma ma'am to start the session.
Ma'am, now you can share the screen.
Ma'am, I am starting to share my screen.
Okay, ma'am.
Ma'am, my screen is visible.
Yeah, ma'am, it's visible. Yes. You can put it in slideshow mode.
Okay, ma'am.
పాపలు खाना पीना
Yes, ma'am, it is now clear.
Okay, ma'am. Okay, ma'am. Good afternoon to one and all. And firstly, before starting my lecture, I would like to thank Head of the Department, Jeevna Jyoti Madam, Principal Madam of RVVR College Management, and all the Chemistry Department members for giving me an opportunity to share my knowledge with BSc first year students on the topic electronic displacement in covalent bonds. So what are the learning outcomes after this lecture will be as follows. There are types of electronic displacement we came to know after this lectures, and they are permanent and temporary, means there are 2 types. One is categorized as a permanent effect and other one is a temporary effect. And what are their applications in various effects? And as जैसे many molecules in organic chemistry are very reactive in particular reaction and many are inert. And the stability of the molecules, their intermediates, reactions, and acidity and basicity of the molecules. When we compare acidity, like aliphatic amines are more basic than aromatic amines. Why this is so? All this we learn in this lecture. And the effect of these electronic displacement in bond length and bond order, also the directive influence of substituent in aromatic ring. Ma'am, my voice is clear?
Yes, ma'am, it is clear.
Okay, ma'am. Okay. So before coming to the core of the topic, I would like to discuss previous lecture. We know that organic chemistry is the chemistry of carbon containing compounds, and we know that they are formed by covalent bonds, and carbon shows tetravalency, and carbon is sp3, sp2 and sp hybridized in organic chemistry, it can have only these three kind of hybridization. The order of electronegativity, if we considered in carbon atom, we found that this is of the, just a minute, ma'am. No. Anode, just pointer is किधर चला गया? पॉइंटर वाला एनोड वाला कहाँ गया इसमें?
Ma'am, you are in mute, ma'am.
Yes. Covalent bonds in carbon compound are two types. One is sigma bond, and it is formed by coaxial overlapping of hybridized orbital. And these orbitals may be sp, ss, and pp orbital. And the second one which formed a covalent bond in organic compound is pi bond, and it is formed by lateral or parallel overlapping of unhybridized p orbital. And it can be formed by only pp orbitals. And there is a picture in which we are showing that the full arrow, which means there is a movement of electron pairs in a particular reaction when we use this kind of arrow. And second one is half arrow, which is also known as fish hook arrow. And this means this arrow indicates the movement of single electron when we discuss various electronic reaction mechanism. Now, what are the electronic displacement? So electronic displacement means when electrons in a molecule moves from one side to the other side of the molecule. And this kind of displacement is often responsible for the various property of the molecules, like their chemical reactivity, means why some molecule is more reactive as compared to other molecules, and also the relative inertness of the molecules. Like chlorobenzene is inert for nucleophilic substitution reaction as compared to aliphatic chloro जो है alkanes के comparison में it is inert. And there are four main kind of electronic displacement, and they are categorized into two categories. One is permanent effect and other is temporary effect. And under the category of permanent effect, we learn inductive effect, resonance and mesomeric effect, and last one is hyperconjugation effect. Temporary effect, under the category of temporary effect, we will learn electromagnetic effect. Now, first we start with the inductive effect. So when we come to introduction of inductive effect, inductive means induce, means whenever there is a electronegativity difference between the two molecules, two atoms in the molecules, then there is a displacement of sigma bond. Means sigma bond electrons are moved from electronegative atom to the other atom which is less electronegative as compared to that atom. And it is operated only in saturated compounds. And due to this displacement, what happens? There is a partial development of charge. Means there is a positive charge develop on that carbon where the electron is shifted to other atom. Like in this slide, we can see that fluorine is more electronegative, and when it is attached to the carbon chain, it, due to more electronegativity of this atom, it attracts electron from this carbon chain. And in this way, this fluorine atom acquired slight delta negative charge. What does indicate delta in this? Means delta means small, which is small in magnitude. Means in inductive effect, there is a small charge developed, where when we represent full negative charge, it means there is a total electron transfer from one atom to the other atom. But in this case, means inductive effect, we have delta. We use delta for magnitude of the charge. And as this effect is spread over the chain, this charge diminishes. Means delta plus is more in magnitude, followed by plus delta 2 or followed by plus delta 3. And so this is in this way the molecule acquires dipole. Dipole means one pole which is negative and one pole which is positive. And as the length of the chain increases, means we can see in this structure, we add next carbon, means carbon 4 here, then this type of inductive effect means electronic displacement vanishes after 3 or 4 carbon. Means it can be only effective at the 3 carbon length of the compound. Now, inductive effect, it is a effect which is overshadowed by other electronic effect, which we later discuss in the next slides, because it is weak in effect. And जैसे कि for example resonance and hyperconjugation effect, which we learn in the next slides, and it also influences the chemical and physical properties of the compounds. And whenever we considering the inductive effect of any group or atom, it is taken with reference to the hydrogens. Means hydrogen has 0 and negative and 0 positive effect. Also inductive effect, as we earlier said, dependent on distance, means it is distance dependent between the substituent of the group, which can be electronegative or electropositive when it is connected to the main group. Now, here we are seeing this kind of effect is of two types. One is positive inductive effect and other is negative inductive effect. In positive inductive effect, the group attached to the carbon chain is known as electron donating group. And whenever this kind of group is attached to the any chain, it will donate the electron to the chain. In this way, the electron donating group will acquire slight positive charge due to the slight displacement of this sigma electron. And as a consequence of this, next carbon adjacent to this group will acquire slight negative charge due to the close proximity of electron, and this charge is spread over the chain. And here we can see at the carbon 3 there is a -3 delta charge. It means carbon 3 has lesser charge in magnitude of negative, and delta जो आपका means C1 is a more negative charge because it is close to the substituent which is donating electron to it. Now here we can see whenever fluorine is attached to the fluorine or any other atom or group which is more electronegative than the carbon, then they attract the electron from the chain like this. Here we can see fluorine acquires small negative charge and carbon acquires small positive charge. So here is the order of inductive effect which shows positive inductive effect, and here is the inductive effect order of negative. Why this is necessary? Because whenever student will solve the question in competitive exams, they will know the effect of increasing order of positive or either negative groups. Here we can see -CH2, -NH and -O. This order of inductive effect, increasing order of inductive effect is often asked in many competitive exams. So when compared with this order, we should remember that whenever there is a charge, negative charge on an atom which is more electronegative, then it is more stabilized. So CH2- is more S in positive inductive effect, means whenever this group is attached to any carbon chain, it will donate more electron as compared to O-. And like this, whenever we consider negative inductive effect, we found that NF3 plus, it is more electronegative index showing, negative inductive effect showing as compared to NR3 plus. And when we compare NR3 plus and NH3 plus, we found that NR3 plus has greater inductive effect in terms of negative. Means whenever it is attached to a system, like we can see in whenever aniline is protonated in case of NS3. When NS3 here and when it is protonated, then this will work as a negative inductive effect. While either here NR3 plus, there are a 3 alkyl group, and in NH3 there is a 3H plus. And as compared to R and H, R is bigger in size, means they are bulky group. So in this case, what happens whenever nitrogen plus is attached to 3 alkyl group, they are due to repulsion between the electron cloud, there is a increase in the bond angle. And here NH3, what happens in this case, as hydrogen is smaller in size as compared to alkyl group, there is no such kind of effect is present. Means whenever there is an increase in bond angle, there is an increase in electronegativity of the atom. As we bond angle means increases, and also the bond angle increases as the space is increasing, and in this way the electronegativity of the nitrogen atom is also increasing when we compare to NR3 plus to NH3 plus. As we know, sp carbon atom, whenever we discuss sp carbon atom and sp2 carbon atom, sp there is a bond angle 180, yes, and 180 bond angle, and here is a character percentage of character S is 50. As the S character is increasing and bond angle is increasing, electronegativity of the atom is also increasing. So in this way, same way here, whenever NR3 plus group is compared with NH3 plus, here due to greater electronic repulsion between the 3 alkyl groups, which are more bulky in nature, there is a increase in bond angle, and due to which more S character and more S character, there is a nitrogen atom which has more elective. So it will show, whenever we compare these two, it will show more negative inductive effect as compared to NH3. But NF3, as we know, fluorine is the most electronegative atom in periodic table, and in this way this NF3 will show highest negative inductive effect order, followed by nitro, then cyanide, then aldehyde, then COH. And one thing I want to share with the students, in some books, author has reported OR behind the OH group, but in Jerry March, it is written with experimental data that OR group is more negative inductive effect showing as compared to OH. And why it is? Because in OR, there is a oxygen and carbon bond, and in OH, there is a O and hydrogen bond. So what happens, as the electronegativity, when we compare in OH and OR, so we found that oxygen and carbon, there is a electronegativity difference less. So less charge separation when we talk about OR. In this case, oxygen and carbon, less electronegativity difference, so oxygen develops less negative charge. So what happens in this way? This negative charge is less, so whenever this OR group is attached to any system, it will attract more electrons from the system. Is it clear my point? And when we compare OH, oxygen and hydrogen bond has greater electronegativity difference, due to which oxygen has slight delta charge, and whenever this delta negative charge and whenever this OH is attached to any system, it will less attract the electron from the system. And whenever we compare the acidity and basicity on the basis of positive inductive effect and negative inductive effect, we should remember that the presence of inductive group, yani ki plus I effect, which is known as positive inductive effect, basicity is increases and जो acidity है it will decrease, means acidity is inversely proportional to the plus I effect and basicity is proportional to the plus I effect. And in this way, when we compare the applications, where in this slide we are seeing application of inductive effect. So what are the applications of inductive effect? Inductive effect, by the use of inductive effect, we can compare the strength of aliphatic carboxylic acid and unsaturated compounds, and relative strength of organic bases like aliphatic bases as compared with tertiary, secondary, and primary amines, and the effect of dipole moment and bond length, and relative stability of carbocation, carbon ion, and free radical due to the positive and negative inductive effect is also can be explained by this. So whenever we consider the acidity of unsaturated compounds, like we have alkene, alkyne, and alkane. So in alkyne, there is a sp hybridized carbon. And as we previously discussed, carbon has sp hybridization and it has 50% s character and 180 bond angle. Bond angle is maximum, s character is maximum. So the electronegativity of this carbon is maximum as compared to ethylene, followed by alkane, where sp3 hybridization and s character is 33% and carbon is less electronegative as compared to alkyne carbon, which have sp hybridization. Now, what are the effect of acidic strength whenever this positive or negative inductive effect groups are attached to any acid? So in this case, we can see acidic strength is directly proportional to negative inductive effect and inversely proportional to positive inductive effect. Here, formic acid is more acidic as compared to acetic acid than propionic and butonic acid. So what is the definition of organic acid? Organic acids, we already know, is lesser acidic as compared to inorganic acids. And any acid has two property, means first property, it will give H plus, means whenever it dissociate, it will give proton or H plus ion. So all acid will give proton or H plus ion. But when we compare the acidity of acids, we should remember two things. One thing, all will give H plus ion, acid all will give H plus ion on dissociation. But the acidic character will be more in that case, where anion formed after the dissociation of proton is stabilized by any factor which stabilize this negative charge and will increase the acidity of that compound. When we compare this with acetic acid and formic acid, here formic acid, after dissociating or losing proton, it will form formate anion and acetate anion. But in case of acetate, what happens? It is this carbon is attached to methyl group, which has positive inductive effect. So what will it do? It will create or donate the electron to the negative oxygen atom. And in this way, it destabilizes the anion by due to repulsion of electron, because oxygen is already having negative charge, and CH3, what CH3 is trying to do? It is also trying to donate electron by a nature positive inductive effect. So there is a repulsion of electron cloud, and in this way, what happens? This anion will combine with H plus ion and go back to acetic acid. But when we consider the compound like formic acid, here we found formate anion on this format anion, there is no such kind of group is attached. Means H has 0 negative or 0 positive inductive effect. So compared to the formic acid and ethanoic acid, formic acid is more acidic as compared to acetic acid. Now, whenever this hydrogen in acetic acid is replaced by any group which has negative inductive effect, like chloroacetic acid. Here, acetic acid, all hydrogen is replaced by 3 chlorine in case of trichloroacetic acid, and in case of dichloroacetic acid, 2 hydrogen is replaced by chlorine, and in case of chloroacetic acid, 1 hydrogen is replaced by chlorine. And we earlier said that chlorine has negative inductive effect, and negative inductive effect groups always increase the acidic strength of the organic acid by dispersing or stabilizing the anion, which we will obtain after protonation. Like we can see here, chloroacetic acid anion is more stable because this chlorine, what will do, it will attract the electron towards itself due to negative inductive effect, and in this way the charge acquired by oxygen atom is stabilized. So in this way, trichloroacetic acid is more stable as compared to dichloro, and followed by chloroacetic acid. And when we compare monochloroacetic acid to formic acid or acetic acid, here we found this kind of order, means chloroacetic acid is more acidic as compared to formic, because here one electronegative atom is present, electronegative atom which shows negative inductive effect, and in this way it will stabilize the anion, followed by formic acid where only hydrogen is present, no such kind of stabilization of anion is present as compared to chloroacetic acid. And when we talk about acetic acid, here is a methyl group is present which shows positive inductive effect, and in this way it destabilizes the anion formed after protonation. And one thing students should remember, as we learned in previous slide, inductive effect is distance dependent. Means whenever this chlorine is attached to carboxylic group, its distance increases, then the effect of this negative inductive effect is also, means whenever this chlorine is attached to alpha, beta and gamma substituted halo substituted acetic acid, then in this case the chlorine ki position, means whenever this chlorine is far from the carboxylic acid, its effect will be less as compared to that chlorine which is nearer to this carboxylic group. Now, effect of basic strength. So base are those which have lone pair of electron for protonations. So when we compare trimethylamine with dimethylamine and methylamine and ammonia, we found this kind of order. But this kind of order is found only in gaseous phase, where we only consider the inductive effect. And as tertiary amine has 3 methyl groups, so it has greater positive inductive effect, and basic strength is proportional to inductive effect. So methylamine is more basic than compared to dimethylamine, followed by methylamine, and ammonia is least basic. But there is a difference in order of basicity when we compare this basis in water or in aqueous solution or protic solvent like water. Then in that case, we have to consider 3 effects. First one is inductive effect, second one is solvation effect, and third is steric effect. Means in gaseous phase, the order of basic strength is according to the positive inductive effect of the group attached to that amine, means nitrogen. But in case of aqueous solution, positive inductive effect, steric factor, and solvation, all three is taken to consideration when deciding the basicity order of these amines. So in case of methyl, whenever R is methyl, then we found order secondary amine is more stable than primary and then tertiary. But when this methyl group is replaced by ethyl group, then in that case, triethylamine is more basic than compared to primary amine. What is the solvent effect? Solvent effect means protonation या H plus ion formation with amine. So in case of primary amine, there is a 2 hydrogen, and tertiary amine, there is an absence of hydrogen. But in case of ethylamine, inductive effect dominant than solvation effect. So we found order diethylamine is more basic than triethylamine, followed by primary amine, and last one is ammonia. Next application of the inductive effect is effect on dipole moment. Dipole moment is the magnitude of charge and distance. And we found CH3Cl has greater dipole moment as compared to methyl bromide as compared to fluoride. And inductive effect of halogen we previously discussed is follows this sequence, means fluorine is more electronegative and then chlorine, then bromine. That's why fluorine exhibits more negative inductive effect as compared to bromide. But the order of decreasing bond length is means carbon bromide bond length is more than carbon chlorine followed by carbon F. And this is why, because largely sized atom, there is a bond formation is not complete, means in carbon and fluorine, there is an involvement of bond formation between pp orbital. And in case of carbon and chlorine, there is an involvement of orbital carbon p and chlorine ki 3p. And in case of bromide, there is an increase in 4p. So what happens, as a consequence of these two effects, they opposes each other, and we will found that this order of dipole moment means methyl chloride has greater dipole moment than methyl bromide, followed by methyl fluoride. And we learn reaction intermediate in 12th also. So here is the order of tertiary carbocation and tertiary free radicals, which can be also one of the reasons of stability of carbocation and free radical. Here we are seeing 3 methyl group are attached to tertiary carbocation, and we know tertiary carbon is those carbon where carbon 3 valency of carbon is attached to 3 carbon atom. Carbon has 4 valency, and whenever here 3 valency of 4 of out of 4, 3 is attached to carbon, that carbon is known as tertiary carbon. And whenever 4 out of 4, there is a 2 valency of carbon is attached to carbon, it is known as secondary carbon. And when we talk about primary carbon, here we see one out of 4, only 1 valency is a bond, covalent bond is bonded to 1 carbon, and it is known as primary carbon atom. And carbocation means it has positive charge. So in tertiary carbocation, here we found 3 methyl groups. So due to 3 methyl groups, they will donate electron to this positive charge carbon, and in this way diminishes or decreases the magnitude of this positive charge. And this can be better explained by hyperconjugative effect, which we will discuss in later slide. And this is the order of various carbocation which found in their relative stability. Here tertiary carbocation is more stable than benzyl carbocation, followed by means allyl cation and benzyl cation. They are almost equal in their stability order: secondary, then primary, then methyl, and last one means least stable is vinyl cation. And when we talk about anion, anion means negative charge, and here is order is reverse as compared to carbocation, because whenever there is an attachment of any group which has positive inductive effect, and due to this electron donating nature, it will donate electron to this negatively charged carbon. And as a consequence, what happens? There will be repulsion or destabilization of this negatively charged ion. So we found order reverse as compared to carbocation, where we found tertiary carbocation is more stable than secondary, followed by primary. But in case of carbanion, here primary carbanion is more stable, followed by secondary, and followed by tertiary. Now, first one we discuss inductive effect, and this is a second effect, electron displacement effect, which is known as mesomeric or resonance effect. Now, resonance and mesomeric effect. Often, usually students get confused between these two effects. There is a slight marginal difference between these two. Resonance is the delocalization of pi electron to pi electron. Displacement is known as resonance in a conjugated system. And what is conjugated system? Conjugated system means there is a double bond, single bond in alternate fashion, that is known as conjugation. And whenever the pi electron is conjugation with lone electron pair or positive charge, and here is a displacement of pi electron with the help of resonance, it is called as mesomeric effect. Means resonance, we know there is a delocalization of electron, but when this delocalization of pi electron or displacement of pi electron involves resonance, and this effect is known as mesomeric effect. And what is the difference between resomeric effect and mesomeric effect? Resonance effect occurs only in one direction, means movements of electron from substituent to system, or either system to substituent. Means whenever any system, a group is attached, and it is electron withdrawing, or it can be electron donating. And whenever it is electron donating, means it will donate electrons to the system. In that case, it is in one direction. And whenever the electron releasing group is attached, donating, it will withdraw the electron, and releasing, it will donate the electron to the conjugated system. In this way, this effect is operate only in one direction. But in resonance, the direction of movement of electron in both the, which will be discussed in later slide more clearly. And so we can say resonance, what is resonance, is the mechanism why which the mesomeric effect operates. Means to have mesomeric effect, there must be a resonance. Definition which is we got according to the IPAC Gold Book, mesomeric effect is as follows: the effect which will definitely create some changes in reaction rate and ionization equilibrium of the reaction mechanism, is attributed to a substituent due to overlap of its p or pi orbital with the p or pi orbital of the rest of the molecular entity. So there is a delocalization thereby introduced or extended, and electronic charge may flow to or from the substituent. This effect is symbolized by capital M or capital R. So there is a kind of resonance. Here we can see in benzene, there is a pi-pi bond resonance, and in RCO, there is a lone pair and pi bond resonance. As we discussed in early slide, inductive effect is of two types, positive and negative. In the same way, we can say resonant effect is of two types, plus R effect or minus R effect. So whenever we have a system like benzene ring, and we see here NH2 group is attached, and this NH2 group, by donating its lone pair of electron to this conjugated system, and that's why it will showing plus R effect whenever it's attached to any system. And when we remove this NH2 group, we found only resonance. There is a resonance. So resonance is necessary for operating of mesomeric effect. Now, what are the groups which shows negative resonance effect? Whenever these groups are attached to any system like benzene ring, they will withdraw the electron from the system, and in this way it is unidirectional or in one direction. So nitro group will show or exert negative resonance effect when it's attached to a conjugated system. In many competitive exams or objective questions, this is asked what are the groups which shows positive mesomeric effect and what are the groups which shows negative mesomeric effect. So here is the list, and how can a student define them between the which group will be showed plus inductive mesomeric effect and which group will show negative mesomeric effect. So for identifying these groups, we have to learn whenever there is an involvement of pi electron, means whenever there is a pi electron involvement, and all that groups will show negative mesomeric or R effect. And whenever there is a presence of lone pair or non-bonding electrons in a group, then these all groups are shows positive mesomeric effect, as we see in this table. Chloride has non-bonding electron, bromide has non-bonding electron, iodide has, alcohol, ethers, and all they have non-bonding electrons. And when these groups are attached to any conjugated system, they will donate this lone pair of electron to the system, and in this way we can identify positive mesomeric effect group. And in this case, here we can see whenever a group is, like we talk about carboxylic acid, here carbon whenever is attached to system, means when an atom which is attached to system is attached to more electronegative atom via pi bond, and all that groups will show negative mesomeric effect. So here we can see all the carbon are attached to the more electronegative atom, which is oxygen, via pi bond. So this all left side groups will show negative mesomeric effect, and right side of the group show positive mesomeric effect. Here we can check the difference between negative and positive mesomeric effect. Upper one, amide, means here is also carbon, and carbon is attached to more electronegative oxygen via double bond. So it will show negative inductive mesomeric effect. And on the right side, acetate, here whenever oxygen is attached to the system, due to this lone pair or non-bonding electron, it will donate electron, and due to the presence of non-bonding electron, we can identify it as a positive mesomeric effect. And here we can see carbon, whenever is at carbon, left side carbon is attached to chlorine, any system, here it will not show neither positive mesomeric effect nor negative. Because here lone pair is not available on carbon atom. So don't get confused with chlorine lone pair of electron, because according to the definition, only those compounds will show positive mesomeric effect which have lone pair of electron. And in this case, carbon is attached to, whenever attached to conjugated system, and this carbon has 4 valency, no lone pair of electron, so it will not show any positive mesomeric effect. While we discuss CS3 group, it will not show any positive or negative mesomeric effect. Because in this case, attached carbon is not attached to other group or atom which is more electronegative, and no pi bond or double bond is present here. So we can say amide is negative mesomeric effect in showing whenever is attached to conjugated system, and acetate will show positive mesomeric effect. Here is the order of resonance, plus R and minus R effect. Inductive effect के case पे, in that case we can see fluorine is more electronegative, showing minus negative inductive effect, and it shows positive R effect in case of chlorine, followed by a bromine and then iodine. And here is the order of inductive effect, and this is the order of resonance and mesomeric effect, and this order will help to us to when we decide the acidity and basicity of aromatic compounds, and when these groups are attached to that system, which we'll discuss in the next examples. We all know aniline shows positive R effect and nitrobenzene show negative R effect. So aniline, in case of aniline, means whenever benzene NH2 group is attached to benzene, it is known as aniline. And NH2 group, due to the presence of lone pair of electron, its electron pair is donated to the system via delocalization of bond. Means this lone pair comes to this carbon and nitrogen bond, and carbon 1 and carbon 2 double bond, pi bond will shift it to this carbon. And as a consequence, what happens at ortho position, negative charge will develop, and this nitrogen develop positive charge, and there is a double bond between carbon and hydrogen, and this dispersion of charge will go into all the system. Okay? And in this way, due to positive R effect, aniline is ortho-para directing. Ortho-para directing means benzene has 2 ortho position, means 2 and 6, and 2 meta position 3 and 5, and 2 para position 1 and 4. Sorry. So in that case, we can see due to this positive inductive effect, aniline, whenever NH2 group is attached to the system, it will increase the electron density of that carbon atom at position, particularly ortho and para. And that's why the coming electrophile, which is electron deficient in nature, will go to ortho and para position as compared to meta. But what happened in case of nitrobenzene? If we do the same reaction in that case, there is a difference in direction of the coming group. Direction of the coming group means whenever nitro group is attached to this benzene ring, this is due to the negative R effect, will withdraw the electron from the system. And in this way, what happens? Plus R plus effect plus sign means the lesser density electron density or decrease in electron density will appear at position ortho and para, which is reversible to NH2 group. So in this way, whenever nitrobenzene will go electrophilic substitution reaction, the coming electrophile will prefer the position meta, because meta has little bit greater electron density as compared to ortho and para. Because due to the nitro group, there is a decrease in electron density between ortho and para position as compared to meta. Meta has more electron density, so coming electrophile will go to that position or prefer that position. Resonance versus mesomeric effect. Mesomeric effect, as I told you, is unidirectional, means whenever any group is attached to system, if it is electron withdrawing, then there is a flow of electron from system to substituent, and when it is electron donating, there is a flow of electron from substituent to system. And that's why we can say all mesomeric effect are resonance effect, but all resonance effect are not mesomeric effect. Now, third kind of electronic displacement is hyperconjugation effect, and it is very important effect in deciding the stability and reactivity of molecules. The word conjugation comes from the Latin word, which means to link together, means to connect two things. In organic chemistry, it is the situation occurs when two pi system, means two pi bond, like here, which is indicated by red. 1 and 2 carbon has 1 pi bond, and 3 and 4 carbon has also 1 pi bond. And whenever these 2 pi bonds are connected by a sigma bond, and this system is called as conjugated pi bond. When we move to right direction, here we can see 4 5 is connected with 5 6, but there is a no sigma double bond, means there is a break of conjugation, means there is link is break. And again here at 6 and 7 carbon double bond is again. So this kind of pi bond is known as isolated. Isolated means akela. And this 1 2 3 4 carbon atom up to 1 2 3 4 carbon atom, this kind of system is known as conjugated system. Now, when we comes to the definition of hyperconjugation, in 1935, Baker and Natha saw that there is a difference of reactivity of electron donating property of alkyl groups whenever they attach to double bond system, means unsaturated system. This is why, because of the another effect which is operating in the system known as hyperconjugation. So hyperconjugation is considered as a special kind of resonance. And what is resonance? Resonance is which occurs in conjugated system via decollocation of pi and lone pair of electrons. So when we try to define hyperconjugation, here is a sigma electron decollocation. Means in resonance, we found pi electron, but in case of hyperconjugation, there is a delocalization of sigma electron to pi bond system or unshared p orbitals. Means there is a sigma pi electron conjugation. Hyperconjugation, as we categorize it in permanent effect, it is like inductive and mesomeric effect. It is also a permanent effect. And the three more terms is used to define hyperconjugation, means whenever there is asked Baker-Nathan effect, it is all hyperconjugation. And whenever we talk about no bond resonance, it is also hyperconjugation. And whenever we talk about pi sigma pi conjugation, it is also hyperconjugation. So these are the words used for hyperconjugation. Hyper means extra, excess. There is a conjugation, but there is an extra conjugation due to involvement of sigma electrons with pi electrons or unshared p orbitals. Is it possible for all molecules to show hyperconjugation or not? There are some conditions which are necessary for a molecule to show hyperconjugation. First one is a compound should have at least one sp2 hybrid carbon atom. Either it can be alkene or carbocation or maybe free radical. And adjacent to this sp2 carbon, there must be a sp3 carbon. And this sp3 carbon has at least one alpha hydrogen. So what are the three conditions? First one is presence of sp2 carbon, and near to this sp2 carbon, one should have sp3 carbon, and this sp3 carbon must have at least one alpha hydrogen. And this effect is seen inductive effect, as we discussed in previous slide. Tertiary butyl group is having greater inductive effect as compared to methyl group. But when we discuss about hyperconjugating effect, we found methyl group is more hyperconjugating, means it denotes electron to the system when it attaches to unsaturated system via more donation of electron. This process sigma to pi, which we'll discuss in later slide. Now, there are three kinds of hyperconjugation. First one is sacrificial hyperconjugation, and example of this hyperconjugation is unsaturated system or molecule. And second one is isovalent hyperconjugation, and third one is reverse hyperconjugation. Sacrificial hyperconjugation, there is a movement of sigma, conjugation of sigma and pi or p orbital. And isovalent, there is a sigma and plus orbital conjugation. And reverse hyperconjugation, what happens? Reverse means opposite. Reverse mean opposite. And as we said, there is a sigma and pi conjugation. So if there is a pi and sigma conjugation, means reverse of hyperconjugation is happening in any molecule, for example, alpha haloalkenes, then we can say this kind of hyperconjugation is reverse hyperconjugation. And when we talk about the stability of hyperconjugation structure, we should calculate the number of hyperconjugating structure, means n plus 1, which is total number of hyperconjugating structures, where n is total number of alpha hydrogen present on alpha carbon, which is adjacent carbon to sp2 carbon. Here we can see this is carbocation and it has vacant p orbital and sp2 hybridization. So one condition is sp2 carbon is must. Second condition is near to sp2 carbon, there must be a sp3 carbon, which is here sp3 means CH3. It has sp3 carbon hybridization. And here is a delocalization or transfer of electron from this sigma to this vacant p orbital. So sigma pi conjugation is known as hyperconjugation, or it is extended conjugation. And when we talk stability, then we have to calculate the number of hyperconjugating structure in that case. And this picture shows the sacrificial hyperconjugation example. It is happens in propene. Here, carbon and hydrogen has sigma bond, and this carbon-carbon has double bond, means single p orbital electron and single p orbital electron of this carbon and this carbon makes pi bond. And when this hydrogen sigma bond comes in conjugation, what happens? This electron goes to this p orbital of the CH2, and in this way this CH2 acquires negative charge and this hydrogen acquires positive charge, but it is not released during this bond transfer here. So that's why it is known as no bond resonance. As we can see here, there is no bond between hydrogen plus and carbon. So this is the example of sacrificial hyperconjugation. Now, student, how can they differentiate or define sacrificial isovalent if two species are given here? Sacrificial means sacrifice. We are sacrificing something. Like this, when we talk about sacrificial hyperconjugation, we see that here is a 9 bond before hyperconjugating structure, means transfer of sigma bond or pi bond to. Here we have 8 bond, means when we calculate 2 hydrogen sigma bond 2, 3, 4, 5, 6, 7, 8, or 1 hydrogen is there 9. And when we see in this resonating structure 1, 2, 3, 4, 5, 6 and 7 and 8. Here, one bond which was formed between C and H is sacrificed during hyperconjugation. And that's why this hyperconjugation is known as sacrificial hyperconjugation. And when we talk about isovalent, iso means same. Here we count total number of pi and sigma bond. 3 from hydrogen, 3 from hydrogen, 6, 1, 2, 3, 9, 10, 11, and 12. So in here, 12 bond, and after this hyperconjugating structure, 3 from hydrogen, 3 from hydrogen, 6, 7, 8, 9, 10, 11, 12. So again, here is a number of bond is same. So we can say if the total number of sigma and pi bond remains same, such kind of hyperconjugation is known as isovalent, and when there is a sacrifice of one bond, it is known as sacrificial hyperconjugation. Isovalent hyperconjugation found in radical stability means free radical, which are odd electron species and carbocation. And here we can see this carbon is sp2 hybridized, and to this sp2 carbon, one carbon which is sp3 hybridized, and it has alpha hydrogen, 3 alpha hydrogen. So this tertiary carbocation has 3 plus 3 plus 3 means 9 alpha hydrogen. So number of hyperconjugating structure will be 9 plus 10 means 10 hyperconjugating structure is shown by tertiary carbocation, followed by secondary which shows 7 hyperconjugating structure due to 6 alpha hydrogen. 6 plus 7 equal to 7. And in primary carbocation, here only 3 alpha hydrogen is present. So number of hyperconjugating structure will be 3 plus 1 equal to 4. And these are the hyperconjugating structures. Here we can see this carbon hydrogen bond shift to share this sigma bond comes in conjugation with this p orbital of the carbon plus, and in this way double bond is formed in between these two carbon, and this hydrogen will be positive and there is no bond between carbon and hydrogen. And in this way we can also use a term non-bond resonance. And after this resonating structure, again second hydrogen will come in conjugation, third, and in this way all 9 alpha hydrogen will take participation in hyperconjugation. So total number of alpha hydrogen will be 9. Alpha hydrogen means a hydrogen attached to alpha carbon. And what is alpha carbon? Alpha carbon is carbon next to positive charge or double bond or any functional group. So we can count here 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Means total 10 hyperconjugating structure be obtained in case of tertiary carbocation. And it depends on the presence of number of alpha hydrogen. As much as alpha hydrogen is present, more of the hyperconjugating structure, and in this way that system will be more stable. Now this is the example of reverse and negative hyperconjugation. Here we can see CCl3. Here this pi bond due to this electronegative chlorine shifted to this carbon and carbon, and as a consequence what happens, a double bond between this carbon and carbon formed, and this carbon will acquire positive charge because its electron is transferred to this carbon due to formation of pi bond. And what happens to next resonating structure? Here the next pi bond will sorry, here this pi electron shift to this carbon, and in this way the positive charge on this carbon will goes, and the positive charge will come on this carbon. This structure is after this, and when this carbon has positive charge, this pi bond is shifted to this carbon, means 4 and 5 carbon, And in this way, the positive charge comes on this position. And this is due to the pi and sigma conjugation, which is reverse of hyperconjugation. And in this way, it is known as reverse or negative hyperconjugation. And this can be seen in this system also when CCl3 is attached to double bond. We know that toluene is ortho-para-directing, and this ortho-para-directing effect is much better explained by hyperconjugating structures. And this CH3 group is attached to this benzene ring, and there is a sigma bond formed between CH bond is shifted to comes to conjugation with this pi bond, and as a result, what happens? The electron density is increases between these two positions, which are ortho and para. And this way, the coming electrophile will go to that position. And S here is a 3 alpha hydrogen, means 1, 2, 3. So number of hyperconjugating structure 3 plus 1 means 1, 2, 3, 4. So toluene has 4 hyperconjugating structure, and it is ortho-para-directing. Ortho-para-directing or meta-directing means whenever there is a substituent already present in system. System is benzene. Okay? When there is a any group which is present, it will direct the coming group whether he has to whether this group will go to for attack, and it will also depends on the nature of the attacking species. Like whenever toluene goes electrophilic substitution reaction, the electrophile will go to this ortho, means 2 and this is 5, 6 position, and para position, which is 4. And here, can we say this compound will show hyperconjugation? What are the necessary conditions we told you? First one is presence of sp2 carbon. So we can see here sp2 carbon. Yes, here sp2 carbon is present. Next condition is presence of sp3 carbon next to sp2. So this carbon is sp2, and next to this is carbon is sp3. Second condition is also completing in their respect. Third one is presence of alpha hydrogen on sp3 carbon. Is it present? Here we can see this carbon is alpha or sp3, but there is no alpha hydrogen, because here 3CH3 group is attached to this sp3 carbon. So although it is fulfilling the two conditions, first two conditions, but third condition is not fulfilling, so this compound will not show hyperconjugation. When we see acetonitrile here, this carbon is sp2 hybridized. Yes, first condition is complete. Second carbon is sp3 hybridized, and it also have 3 alpha hydrogens. So this molecule will show hyperconjugation, but this molecule will not show hyperconjugation. In exams, whenever we compare the relative stability of substituted alkenes, so we found following order, means most substituted alkene are more stable than least substituted or unsubstituted alkene. Why is it so? Because most substituted alkene has more hyperconjugating structure due to the presence of more alpha hydrogen, and in this way systems stability increases as compared to unsubstituted alkene. And when we compare the stability order of disubstituted benzene, we found geminal alkene is more stable as compared to trans, and as which is followed by cis. So every student, we already know in many books, trans and geminal, there is a trans, more stable trans alkene than geminal, but when we draw the hyperconjugating structure of geminal alkene, we found that after hyperconjugation, carbanion which is formed, it is primary. And this primary carbocation is more stable as compared to this carbocation, which is secondary in nature. Because this secondary carbocation, as we previously studied, is less stable than primary. So geminal alkene, when we compare with its trans, is more stable than cis. Cis means whenever two alkyl groups are on the same side of the double bond. And trans means opposite. Opposite means whenever these alkyl groups are opposite to this double bond. And what is geminal? Geminal means when two R group are attached to one corner or one side of the double bond. So this was the order.
Ma'am, you are on mute, ma'am.
I know that is, but what happened with this? Okay. Now, when all these three effects, which are categorized in permanent effect, that is mesomeric, hyperconjugative, and inductive effect, and they comes in one molecule, when they operates in one molecule, then this is the order of their dominance. Means mesomeric effect will dominate over hyperconjugative effect, and hyperconjugative effect dominant will inductive effect. Because inductive effect, there is a only partial delocalization of charge, so it comes at last. And mesomeric effect, there is a conjugation between electrons by delocalization. Thus, stability of the system in this way increasing and energy is decreasing. And when we talk about hyperconjugation, here we have to serve sigma bond, which are stronger as compared to pi bond. So, and there is a transfer and delocalization of charge. So mesomeric effect is more effective, more dominance when we compare hyperconjugation and followed by inductive effect. And this will be cleared when we discuss some examples. Now, application of hyperconjugation. Hyperconjugation effect on bond length as well as dipole moment. When we talk in, take example of nitromethane, here due to hyperconjugation, this sigma bond gets in conjugation with nitrogen and oxygen pi bond, and due to which in first structure carbon and nitrogen bond is single bond character, and here carbon and nitrogen is double bond character acquires. So in this way, due to this hyperconjugation, carbon nitrogen single bond is not pure carbon nitrogen single bond, and this carbon nitrogen is not pure carbon nitrogen double bond, and this will for consequently result a change in carbon experimental carbon nitrogen bond length. We can explain the acidic property of phenol by taking example of positive R effect. Positive R means a substituent which has lone pair of electron when it is attached to system. So here is system benzene, and which is a group or atom which has lone pair of electron. And as we told you earlier, any organic acid is acid. When it dissociate, it will give H plus. So first condition is fulfilled, acid is acidic. But second, we have to check whether this oxide, phenoxide ion, after losing proton, is better stable as compared to this phenol or less stable. And this point will decide the stability or acidity, or acidity of phenol. So when this phenol dissociate, it will give H plus and convert into this phenoxide ion, due to which when this proton dissociate, this phenoxide ion will generate, and this phenoxide ion gets in conjugation, this lone pair gets in conjugation with this system, and due to which we get these resonating structures, and these resonating structure we can see there is no charge separation, means only negative charge is on the whole molecule. But when we see in case of phenol, here oxygen, which is more electronegative as compared to carbon, has positive charge, and in this way phenol is resonating structure has a lesser stability, and this negative and positive charge also requires separation. So phenol, when goes into resonation, is less stable, and after giving proton, it got better stability due to resonance, this delocalization of this lone pair of electrons, and there is a no charge separation as compared to phenol. So phenol is more acidic, and the reaction goes from left to right or forward direction. Chloroalkene यानी कि aryl halides are less reactive towards nucleophilic substitution reaction. As we know that like aryl halide, there is a readily susceptible to nucleophilic substitution reaction. But when we talk about the aryl halide, here chlorine and carbon and chlorine bond, due to this hyperconjugation, acquires again double bond character, and double bond is more, double bond length is shorter, and it is requires more energy to break it. So this chloride is less susceptible to replaced by any nucleophile, and in this way aryl halides are less reactive towards nucleophilic substitution reaction. But when we talk about chlorobenzene, in chlorobenzene chlorine is orthopara directing, so we can see due to this donation of electron density at ortho and para position is increasing, and in this way the coming electrophile will go to that position. Now we are going to discuss comparative study of substituted phenol. So acid means OH, COH means which are capable of giving proton. So phenol, when gives proton, it will form phenoxide ion. So here is the all are phenol, means OH will convert into O minus. But the substituent which is attached to all these three phenol is different, means OMe in first case, Me in second case, means methyl, and nitro in third case. So when this type of question comes in exam, we have to see the effect which the group contain, means positive or negative inductive effect, mesomeric or positive mesomeric or negative mesomeric effect. In case of Methoxy group, means OMe, it has positive inductive effect and positive mesomeric and resonance effect. But in case of methyl, only positive inductive effect. And when we talk nitrophenol, here negative inductive effect and negative mesomeric effect. And we studied earlier in previous slide the factor which stabilizes the negative charge, the factor or the group which stabilizes the negative charge will show more acidity as compared to other. So in this case, nitro group, due to negative inductive charge, negative inductive effect and negative resonance or mesomeric effect, withdraw the electron and stabilize this phenol after dissociation, and compared to methyl, where only inductive effect is operating. And this inductive effect, here we are seeing methyl group is attached to 1, 2, 3, and 4 carbon, and this inductive effect is distance dependent. So the magnitude of electron donation is less in the para position, at the para position. And last one is methoxy group. Here what happens? Plus I effect and plus R effect, it will donate electron to the negatively charged oxygen. And in this way, it destabilizes this phenol most as compared to these two. So it will come at last, means third, and this will come at first place and this will come at second place. So order of acidity will be third will be more acidic, then second, and then 1. Now, substituted benzoic acid. Here we are seeing benzoic acid which has para position different substituent. First one has nitro group, second one has chloride group, third one has methyl group, fourth one has methoxy, and fifth one has phenol OH group. Okay? And when this benzoic acid dissociate, it will form benzoate anion after losing H+. So whatever group stabilize this negative charge by dispersing through conjugation will be more acidic. Let's count their effect. First, when we talk para-nitrobenzoic acid, here nitro group has negative inductive effect and negative resonance or mesomeric effect, means both effects are negative. So this will stabilize more this benzoate anion as compared to all this substituted benzoic acid. And when we comes to para-chlorobenzoic acid, here chlorine has negative inductive effect but positive R effect. And at para position, negative inductive effect and para position resonance, yani means resonance effect is positive but inductive effect is dominating. So this acid will be more stable, more acidic, but less acidic as compared to nitrobenzoic acid. Third one is benzoic acid. Here is no substitute attached, so it will come to third place. And when we compare in these three, here we have to written the effect they shows, means methyl has only positive inductive effect, and OCH3 methoxy group has negative inductive effect and positive R effect, and OH has negative inductive effect and positive mesomeric or resonance effect. So this will be the order of the increasing acidity when these substituents are attached to para position in benzoic acid. This methyl group is having positive inductive effect and no resonance or mesomeric effect, so it will come after benzoic acid in terms of acidic character, because inductive effect is diminishes from distance, or here methyl group is attached to 4 position and distance is increasing from anion, so it will come at 4th place. And when we compare OCH3 and OH, we found OCH3 when attached to para position, it will be more acidic as compared to para OH group. Now, last one displacement effect is electromatic effect, and it is a temporary effect. All three we learn is kind of permanent effect, and this effect is temporary effect. Temporary means for a time being. Time being means whenever there is an attacking group, in that case, there is a shift or transfer of pi electron in multiple bonds, and this kind of effect is known as electromatic effect. Means whenever there is a presence of reagent, there is movement of electron from one to another atom and charge species are formed, and when this reagent is removed, they again combine and form multiple bond. So this is a reversible reaction, means reaction can proceed to both sides, and there is a complete transfer of pi electron. That's why A acquires total positive charge and B acquires negative charge. It means full negative means total transfer of electron from A to B, and plus charge means total loss of electron. While in case of inductive effect, what we learn, there is a partial shifting of charge. Partial means slight delocalization, slight shifting. So in that case, delta is used for depicting charge. Delta means small in magnitude. But when we show this positive and negative charge, means there is a complete removal, complete shift of electron from A to B. Like other electronic effect, electromagnetic effect is also two types. First one is plus E effect or positive electromagnetic effect, and second one is negative electromagnetic effect. How can we identify which group is showing positive electromagnetic or in a molecule plus E effect or minus E effect? It occurs when shared electron pairs is transferred towards attacking reagent. Means there is a movement of electrons in the presence of attacking reagent towards that atom where attacking reagent is attached. And this type of electromagnetic effect is known as plus E or plus positive electromagnetic effect. Example of this reaction is protonation of alkene, which we will discuss in later slide, where attacking species is electrophile, that is H+. Electrophiles means those species which are electron deficient, means they are electron loving, unko electrons chahiye. And negative inductive effect means when shared electron pair is transferred away from the attacking group. Means whenever there is an attacking reagent, there is a movement of electron away from the attacking group, and this kind of electromagnetic effect is known as negative electromagnetic effect. And example of this reaction is addition reaction of cyanide to carbonyl compound. And attacking species is nucleophile in case of cyanide ion. Here, this is multiple bond, and whenever this positive species means electrophile attacks, there is a polarization of charge electrons, and electron pi electron shift from this carbon to this, and this attacking species attached to this carbon, and that's why this H+ is showing plus E effect. And in this case, what happens? Movement of electrons away from the attacking group, means attacking group is attaching to that carbon where electron is shifted to another carbon, and in this way it shows negative electromagnetic effect. And what are the differences between the electromagnetic and inductive effect? We can summarize in this table. Inductive effect is a permanent kind of effect, and it is a temporary effect, means whenever there is attacking group, then only its effect will happen. In the presence of multiple bond is not essential in case of inductive effect, while to happen electromagnetic effect, there is a multiple bond essential. Polarity of bond, because inductive effect operates due to the difference electronegativity between two atoms, so polarity of bond is essential to happen inductive effect. While in case of electromagnetic effect, polarity of bond is not a necessary condition. Partial charge separation. Partial means little shifting of the electrons, due to which partial charge, positive or negative, will develop to atom. There is a complete charge separation takes place, means electromagnetic, because there is a total transfer of pi electrons. Sorry. So there is a complete charge separation. In inductive effect, no ions are formed because only partial charge develop. Here ions are formed due to the total transfer of electrons. Attacking reagent is not required. Kyun? Because the group which is donating electron to the carbon chain or attracting or withdrawing electron from the chain is permanently attached to that system. So attacking reagent is not needed in this case. Here attacking reagent is required, means attacking reagent, in the presence of attacking reagent, electromagnetic effect will be happened only. The displaced electrons do not leave their molecular orbital, means they only shift slight bit. That's why distortion of electron position cloud will takes place. And in this case means electromagnetic effect, displaced electron leave their orbital and attain new position. Here, Mayer again, same point is there, displacement of electron. Here is a complete transfer of pi electron. So this was the inductive effect, difference between inductive and electromagnetic effect. Let's last slide. We will summarize what we have learned till yet. 4 kind of electron displacement we learned in this lecture. First one was inductive effect. Second one was mesomeric. Third one was hyperconjugative. Fourth one was electromagnetic. Now let's summarize at a glance. Inductive effect was permanent effect is only displacement of sigma electron. Means inductive effect, there is a displacement of sigma electron and partial charge develops on the atoms. Mesomeric effect, it is permanent effect again, and there is a displacement of pi electron with the help of resonance. Means all resonating structures, all mesomeric structures will be resonating structure, but all resonating effect are not mesomeric effect. And hyperconjugating effect, permanent effect, and here delocalization of sigma bond, sigma electrons from sp3 carbon having at least one alpha hydrogen atom with pi bonded sp2 carbon atom. And it is also known as sigma pi conjugation, no bond resonance, Bacon-Natha effect, and a special kind of resonance. These 4 terms, sigma pi conjugation, no bond resonance, and Bacon-Natha effect, is used for describing hyperconjugating effect. Last one which we learn, electromagnetic effect, temporary. It is a kind of temporary effect, and it occurs only in the presence of attacking reagent when there is a total transfer of pi electron from one atom to the other atom, and charge species is formed in this case, and when this attacking reagent is removed, the charge species gets combined and back to that original moiety. And this was the today's lecture. I hope students will like my lecture, and thank you. Stay safe and healthy. And if anyone has any question, can ask.
Thank you, madam. Girls, if you want to interact with madam, you can unmute yourself and you can ask your doubts. I think, ma'am, it's crystal clear. You have covered all the concepts which are useful for their competitive exams as well as for semester exams. So I think you have covered the entire unit in 1.5 hours, madam. Thank you so much.
Thank you, ma'am.
Shravanti, if there are no questions, you just continue with the schedule.
Okay, ma'am.
Ma'am, Jyoti ma'am.
Yes, Prasanna.
Ma'am, can you make co-host me Prasanna Kama?
Okay.
One more it is there, ma'am.
1 second. Shall I share from my side?
Oh, okay, ma'am.
Okay, right. Ma'am, can you stop sharing so that we can share our screen? Thank you, ma'am. Prasanna, continue. 1 second. One second, I'm just sharing the screen. Shravanti, can you do me that? I think okay. Now I think it is visible.
Yes, ma'am. It is visible.
Okay, right. Okay. Ma'am, from Department of Chemistry, we would like to present appreciation certificate. Kindly accept our certificate, ma'am.
Thank you so much, ma'am.
Okay. Prasanna, you can continue now.
Okay, ma'am. Good afternoon to all. It's a great honor and privilege to propose the vote of thanks our guest speaker, Dr. Geeta Verma, Assistant Professor, Department of Chemistry, Chandrasekhara Azad, Government PG Nodal College, Sehar. Ma'am has explained about inductive effect, mesomeric effect, and hyperconjugation, and also electromagnetic effect and their applications. It is very useful to our student, ma'am. My grateful thanks to head of the department, Dr. V. Jeevan Jyoti, ma'am, and faculty for their support. Once again, I thank one and all present here. Thank you, ma'am.
Thank you, madam. Prasanna, you can share the feedback form to students in the chat box.
Okay, ma'am. Okay.